much. Good morning, everyone. Good morning. My pleasure to be here, to learn from what is happening here in Eastern Africa, and also to be able to talk a little bit about what Esri is preparing and what we're thinking and how we can help you to be successful in your GIS projects. Been here for a few weeks and I've enjoyed a few safaris, and we have another one tomorrow. Some of you will join us on the safari tomorrow, which I guess involves a boat. My safari last weekend involved a bike, and I explored a few Chaga villages up on the mountain, and it was very interesting, and very much enjoyed myself. Amongst other things, I'm a GIS professor. So I've been teaching GIS for 20 years, since '97. Primarily at a university in Spain, which is called the University of Jaume I, which is not in Catalonia, but near Catalonia, where we've had some news lately. And I teach in an international master's degree program with 15 students, always 15 students, who are sometimes a little bit, well, sometimes they don't come to class on time, sometimes they're a bit tired. So I'm very comfortable this morning. Always teaching to 15 students. So here I've got more than 15, and I'm happy to see that. I'll talk a little bit about the types of things that we're teaching around the world. I joined Esri in 2008. So here's the headquarters in California. One of the things that we like about Esri is that Esri is a privately held company. It has two owners, Jack Dangerman and his wife Laura Dangerman. So we're not influenced by investment bankers and by shareholders. We can develop the software and the services that our users are looking for, and we can really focus on our mission. We don't have investors moving us, trying to move us in different directions. I feel privileged to be on the education outreach team and to be standing on the equator. This happens to be a particular point in the equator in Uganda, but this is a sort of a theoretical equator between, on the right side, 350,000 Esri users. These are municipalities, these are oil companies, these are, for example, I've got 3 examples here. FedEx, which needs to make sure the packages arrive on time. They run their logistics system utilizing GIS. Or in the middle, Swiss Topo, creators of perhaps the finest topographic cartography in the world, utilizing ArcGIS to produce this cartography, to publish it. Or the Panama Canal Authority, which has a very interesting linear view of the world. And they need to control this linear world of theirs, ships coming in, ships coming out, utilizing GIS. So these are just 3 examples of our 350,000 large institutions that are utilizing the software. So that's on the right side. On the left side of my equator, we've got 11,000 universities using Esri software, including many in Eastern Africa. In addition to countless museums, libraries, schools, and other educational institutions. So my team works on the equator, on the bridge, let's say, between these 2 worlds. So we visit universities and other educational institutions, and we try to bring some of the knowledge coming from the side of our users to the university and to the educational world. And then we try to help our large users to educate themselves, because learning is a lifelong activity. So it's a really interesting balance. What's happening with GIS, what can happen with GIS, and how can the universities and other educational institutions feed the future users and creators of GIS applications. We're led by Jack, and you had a quick glimpse of Jack in the first morning session. In his video, he's got a soft spot in his heart for Africa. He's happy for us to work with African institutions, and he's always got a new idea. And I've been in contact with him in the past few days. He has another idea for further support in Africa, and I can't say much more about that now, but you'll have some nice news in the near future. This is one of Jack's slides, which I stole a few years ago, and I really like this slide because this talks, I think, very clearly about why we're doing what we're doing. Why does GIS exist? Why are we working in this world of GIS? And I think people outside of our world would answer, so you can make maps and hang them on the wall. But there's much more to it. The world has some really serious problems, and some would say the world is sort of on a downhill slope regarding some serious economic, environmental, and social problems. We truly believe that GIS can help us to solve some of these problems. And we really believe that when more people are utilizing GIS to model their world and to solve problems utilizing this technology, that at some point we're going to be capable of pulling out of this nosedive and to start rectifying some of these situations. The reason why I like this slide is because down at the very corner there's a little kind of subliminal message, and some of that's cut off, unfortunately, by the resolution of the screen. And what it says is that we can create a better future. And how does Jack think we can create a better future? Based on GIS, science, technology, and education. And what he believes, and what I believe, and what our team believes, is that education is the key. Because technology is not going to fix these problems. People are going to fix these problems. And the way that people fix the problems is by changing their behavior. And that's education. So education is changing people's behavior, such that fewer people are smoking these days, such that in certain countries people are not utilizing plastic bags. Little things. We're starting to use more public transportation in the US. So little, small changes, small behavioral changes are affected by education. We think that's what's going to help to fix some of these problems. So we're very happy to work with educators at all levels. And this is what we normally think of when we think of education. College level students sitting in the classroom doing their GIS exercises. This happens to be in Myanmar, but I could have shown you examples from lots of different countries. But there are also informal educational activities, such as summer schools in Rwanda, after-school activities, hackathons. We support these activities. These are very, very important because people are learning outside of the classroom. Equally important is adult, continuing, and lifelong learning. Retraining. Imagine if our medical doctors who studied 40 years ago never got updated training on the newest therapies and on the newest medicines. We'd be in dire trouble. Imagine if airline pilots learned how to fly an airplane with propellers 40 years ago and never updated their skills, and now are flying Airbus 380s. We'd be in dire straits as well. All professionals pretty much need to renew their education. They need to be retrained constantly. We all do. So our view of education is that increasingly we're not talking about students, because when we talk about students, people think, oh yes, I did that. That was the first 15 years of my life. I studied and then I moved on. And now I'm in the working world. We focus on learners. We're all learners. And learners can be 8-year-old children using our software, and we have them. And they can be 80-year-old people using our software, and we have those as well. People who are continuously updating their capabilities, not only regarding technology, but also regarding methodology in the way that we can apply the technology. So we focus on learners. We produce learning materials. And we talk about learning activities. To us, the bedrock of what we're learning and what we need to understand is not mapping. And some people, as I mentioned, would consider mapping to be the bedrock or the sort of the foundation of what we're studying. We think we can even go lower, and we should go lower. And to us, the bedrock is spatial thinking. Even before we start thinking about maps and making maps and using maps, spatial thinking is what we think is at the core of what people need to understand and what we're doing with GIS. So spatial thinking is a series of ways of looking at the world in multiple dimensions. The ability, for example, if I were to ask you to point north right now, some of you would do a pretty good job at showing me where north is. I frankly don't know where north is, right? But some of my other spatial abilities are more well developed. We learn about configurations in cities through experience, and we build our spatial knowledge through experience. So the first time we visit a new city, all we know is one route from the hotel or from the airport to our hotel. And then day by day, we start acquiring more configurational knowledge of the city as we explore more routes in our taxi or in our own car. So spatial thinking has been defined as a type of intelligence. For many years, we thought there was one measure of intelligence, IQ. And so you took a mathematics exam, and you took a language exam, and you got a number. It still happens at many universities, right? You get a number, and that's how smart you are. Well, psychologists many years ago at Harvard University and other places started talking about alternative intelligence. Not everyone scores very highly on a mathematical exam, but maybe they score very highly on an exam or activities that have to do with musical abilities, or they're chess players, or they've got physical abilities as a dancer or as a sportsman or a sportswoman. So they're alternative intelligence, including spatial intelligence, which is on their list of the types of intelligence that a person can develop. And just like someone can develop their mathematical intelligence or their language intelligence, they can develop their spatial intelligence. How to understand better their world, how to, for example, do something as simple as looking at a drawing or a map in 2 dimensions and imagine this world or this object in 3 dimensions. These things can be taught. And so there was a psychologist called Maslow who in the 50s and 60s published a series of papers talking about a pyramid of human needs. A pyramid of human needs, and how there's a sort of a hierarchy of basic human needs and then more higher level human needs as we go up this pyramid. And this is interesting for us to consider because we're asking spatial questions, we're trying to solve spatial problems. And these can be at different levels. At the base of our pyramid, we've got physiological or biological needs. Every human being needs to be able to cover these basic needs: food, respiration, sexual reproduction, or else our species disappears off the planet. So there are these basic biological needs. Once we've covered those biological needs and we can survive, then we can start thinking about higher level needs, such as security, making sure we have a roof over our head, making sure that we're not being attacked by our enemies. Once we've got those needs satisfied, we can start thinking about family, friendships, relationships. And then higher level, self-esteem, respect of others, etc., etc. And then at the highest level, when we've got our basic needs and our intermediate needs covered, then we can start becoming creative. And we can start thinking about problem solving and acceptance of facts. We can become scientists. Whereas science is not strictly necessary. First we need to make sure we've got food and shelter, etc., etc. And then we can start becoming creative. And we can become scientists, and we can become problem solvers. So I think it's always interesting for us to think of the fact that all humans throughout history have had this hierarchy of needs. And so let's think of what are the geographical fundamentals in this respect. Human beings, even when they were living in caves, were asking basic spatial questions about their environment. Where are we? Not only individually, but where are we with respect to our enemies and our friends? What's nearby us? How can we navigate across the river to get that firewood? How do changes nearby us affect us? There's a forest fire. Is this going to affect my neighborhood or is it not going to affect my neighborhood? So there have always been spatial questions that we've asked for survival and then for other of our needs at a higher level. And this continues today. We're still basically asking these same kinds of questions. How do I get to work given the traffic situation in Dar this morning? Which is different than the situation in the afternoon or the situation yesterday. And there's a series of spatial questions that we will continue asking in the future. So a short while ago, I was asked to talk about the future of GIS. And the topic that I was given was the previous 20 years of GIS and the coming 20 years of GIS. And I thought, I don't have a crystal ball, no one does. However, I do have a pretty clear picture of what the future is going to be for GIS, because I can see what has happened over the past years and how we have adapted. And it's a very simple formula. Technology will change. It has always changed. And we will adapt with the changing technology. GIS has never really been an inventor of technology. We've always adapted to someone else's technology. So we took on the mainframe computer that someone else built and said, thank you, we'll use that. And we borrowed from the database management systems community, or we borrowed from the remote sensing image analysis community, and we borrowed from the CAD community. And we continue to do that. So as mainframes become mini computers, become PCs, become phones, we adapt with these changes. And when we move from collecting our own data to utilizing satellites to flying our drones, we adapt to these changes. What hasn't changed over the past few thousand years are these basic questions. So my view of the future is we'll be asking these same questions in 1,000 years. These questions will not change. We'll have perhaps better technologies to allow us to answer these questions faster, more efficiently, cheaper perhaps. So that's my view of the future. We will continue to ask these basic questions with better assistance from technology, hopefully, and we'll adapt to these new technologies. These geotechnologies have been around for a while. We started drawing maps in the sand, and then on clay tablets, and then on papyrus. Now it's computerized. So geotechnologies have evolved, but we're utilizing them for similar objectives. Navigational technologies, compasses, and other apparatus for navigating in ships or in vehicles. And I've added the church steeple here, which might surprise a few people. The church actually provided us with a couple of interesting geotechnological artifacts or tools, because the church decided that they wanted to start regimenting our lives, right? They wanted to make sure that we knew when Mass or when service was, and they wanted to call us. So they built a tall steeple so we could see it from no matter where we were in the fields. We didn't lose sight of the church. And the church actually, historically, pushed the creation of the clock such that it could help us to regiment our day and make sure that we showed up to church on time. So the church pushed the development of the clock and started reminding us. In some religions, you're reminded 4 times per day, starting at 5 in the morning. In other times, in other religions, you're reminded once a day or once a week. Right? So this is an example of some of these artifacts or some of these tools that were created to help us, to guide us. And so these tools are evolving. Roll the clock forward a bit from the caveman times. And I think some of you have seen this map and you know the story here. 1854, a cholera outbreak in the Soho neighborhood of London. Hundreds of people dying. And the experts trying to figure out what's going on here. And so they didn't understand cholera. They didn't know if it was airborne, if it was from food, from water. They didn't know how it was transmitted. They didn't understand the disease. But they knew a lot of people were dying. So people started analyzing lists of victims. What did they have in common? Did they live together? Were they all young people? What were their commonalities? What were their common traits? And so a medical doctor, John Snow, decided he was going to plot the deaths on a map. So he started looking spatially at the problem. And surprise, surprise, there was a big stack of people near a particular water pump on Broad Street. So they thought, okay, let's give it a try. Let's turn off the water pump on Broad Street, and sure enough, the cholera outbreak slowed and then eventually disappeared. So this is considered to be one of the sort of prototypical examples, early examples, of spatial analysis. In this case, he was merely plotting the data on the map, and then a message popped out. Spatial thinking. These days, we go beyond that. We don't just plot the data on the map. We've got other spatial analysis techniques to ask more sophisticated questions of this point pattern. How does this point pattern relate to other point patterns or line patterns or areas? And we're looking for causes. Roll the calendar forward another 100 years, and in the early 1960s, a geographer, Roger Tomlinson, in Canada, got together with IBM to create the first geographical information system, commissioned by the Canadian Forest Management Service, and they created the Forest Inventory GIS of Canada. And they didn't just want to see where the trees were on the map. They wanted to analyze the situation. They wanted to take decisions. They wanted to know where to cut, where to preserve, how to manage their forest resources, which is one of their largest economic resources in Canada. Way back in the 1960s, they realized that the GIS was for making decisions. It wasn't just for making maps. This is a film called Data for Decision, which you can find on the Esri website. And you can find it probably on YouTube. So if you search for Data for Decision film, you'll find 3 parts of the film. It's hilarious because it's 1960s style. But it shows very clearly how, from the very beginning, Canada was, of course, managing its forest resources, but it had an army of people with cards and paper to try to get the job done that they then transferred to a big IBM computer and started automating. And they talked very clearly about how they did this, a big investment, because they were going to get back a return on their investment in better decision making, better management of their forest resources. So this was the very essence of GIS from the start. It was never designed to be a map-making system. It was designed to be a map analysis system, a spatial analysis system. Roll forward to the year 2010, and universities in the United States asked the commission to survey, because the universities are always curious to know, what are the employers looking for? In which direction should we be steering our students? So in 2010, they commissioned this study, and they asked employers, what should young people know? And way up in the top of the list was critical thinking and analytical reasoning skills. So this is a kind of a scientific way of, now that I work in a company, I can say, this is a scientific way of saying, we're looking for problem solvers, not problem creators. And in another company, I can take any collection of people and I can say, these are problem creators and these are problem solvers. Right? There are people who always complain and always have a problem, and there are other people who step in and solve the problem. And these are the people I need to move ahead in my institution. So this can be taught. This can be taught, and it's taught by transforming the educational system such that the students aren't just sitting listening to prof and taking notes and then taking an exam at the end of the semester, but they're involved in active projects, and they're doing group work, and they're involved in hackathons, and they're building things. They're solving problems. Related to that is the ability to apply knowledge and skills to real-world settings, through internships or other hands-on experience. So this is what employers are looking for. They're not looking for more masters and more degrees and more degrees and more degrees. They're looking for some degrees in relevant topics, but also the ability to solve problems. And GIS helps people to do that. This has been a real benefit to the use of GIS in any discipline. Not only to become a GIS specialist per se, but to learn how to become a problem solver. And I could say the same thing about using Excel, right? You can start learning to solve problems using Excel, but of course GIS allows us to go far beyond that. If we're not using any technologies for decision making, which of course we did for thousands of years, how do we solve this? How do we make decisions? How do we solve problems? Whoever was the alpha person in our group decided, let's try this, and everyone followed and they tried it. Oops, that didn't work. Let's try this. Okay, experiment, trial and error. So many years ago, we were told that we should be solving problems using data. So Excel or databases can allow us to specify what part of the problem we're really trying to attack, and how do we represent that in digital format, and then we can utilize these tools to help to solve problems. And then people told us, well, a big list of numbers oftentimes doesn't tell us what's going on. If we graph, or if we represent graphically our data, we can see tendencies, and we can see outliers, and we can see something that might be interesting to study in more detail. So we started doing that. And of course, our community says, well, why don't we move even a step further? Why don't we put our data on the map and look at it in 2 dimensions or 3 dimensions? And as is the case for the cholera outbreak, in many cases, just looking at our data in 2 dimensions or 3 dimensions starts indicating where we need to look in more detail. But we need to look in more detail. It's not enough to put the dots on the map and say, here's the problem. We've got a lot of people with cholera in this neighborhood. We need to be asking, why is that the case? And who are these people, and how did it happen? And are there more people with cholera this week than last week? Trends over space and over time. So when I'm teaching my GIS course to the master's students, which I did just a couple of weeks ago before taking the plane here, we utilize a textbook which is called Geographical Information Systems in Science, which is by 4 British authors, Longley and Goodchild and McGuire and Ryan. And amongst the very many interesting things in this textbook, they talk about the 5 M's of GIS application, being mapping, measurement, monitoring, modeling, and management. And I think these are important. Again, because I think far too many people think that the GIS is a tool for us to introduce data into the system in order to plot a map. Mapping, of course, is important. It's fundamental, but it's not enough, right? And so the first thing is mapping. And most mapping is expository. It's just showing us what there is. It's a snapshot of the world. This is what exists. Here's where the elephants are. This is where the poverty is, which is excellent. It's necessary. But then we can move sort of up the hierarchy, or we can move to more higher level operations with our GIS. Measurement. Now some people would say, why isn't measurement first? You need to measure before you map. Well, it depends on what kinds of mapping you're doing. A lot of the mapping these days is thematic mapping that's to go into a newspaper article. And so you don't need to send out topographic engineers to survey exactly where the election boundaries are in order for you to show who won the election, right? But yet measurement can be very interesting for more topographical mapping and for mapping applications and GIS applications where specific position is necessary. If we don't measure, then we can't benchmark for comparison. And so decision makers and business leaders will say, if you can't measure it, you can't manage it. And this goes for employees or sales or anything. If you can't measure it, you can't manage it. So it's important that we're focusing on proper measurement techniques because, as I mentioned, we want to get to a more higher level use of our GIS and do comparisons through space and through time. If I want to talk about urban growth in DAR, I need to make sure that we're talking about the same place. Things need to be properly measured and compared, such that I'm not comparing spurious differences based upon geometries that were improperly digitized. I want to make sure that I'm comparing the same world. Once we've measured things properly, then we can start monitoring, which means change over time, which means process. And many experts these days would be of the opinion that if things aren't changing, then we're not interested in spending much time looking at them. We're mostly interested in change. We want to know, why did things change? Where did they change? Who's being affected by the change? Merely looking at what exists today is not so interesting. I want to know, okay, how is it different from what existed a year ago or 10 years ago? And I want to know, why is this change happening? And where is it happening? And who's it affecting? So I want to be able to monitor situations. GIS allows us to move even a bit further to create what-if models, to be able to model our world. And a model is nothing more than just a simplification of our world. It's not interesting for us to try to represent every grain of sand on the beach when I can represent that by a simple polygon. So we need to be able to model our world in specific themes or a specific aspect of our world to be able to make predictions. And that's a big part of what we do with GIS. No guarantee that the predictions will come true, but we can make speculations based upon previous and current data. And then finally, management. And I think this is an aspect that most of our students never really get a taste of. A GIS, I've seen some definitions in talks just this week. We're always hearing the GIS has 5 parts: the software and the hardware and the people and the data, et cetera, et cetera. GIS is not just something that you do for 3 days and then print your map and then turn off. GIS is in many cases a project, an ongoing project. It's always living. It's a generator that's always running. And so management means maintaining the GIS and updating, keeping the data up to date and ready to go for the next analysis. And it becomes a tool just like our mobile phones and just like our vehicles. It's a tool that we use daily for our business or for our institutional purposes. So many of our young people are not able to see that aspect in their early educational experience. It's difficult to teach about real GIS projects in class, but many of you are now experiencing this, and you're seeing that of all these different components, perhaps it's the people that are the most important. And if you don't have the right people or enough people, then it's really hard to move forward, no matter what tools you have, no matter what data you have. So I think it's interesting for us to consider moving beyond, to the extent possible, pure expository mapping and moving towards these higher levels of spatial analysis. This is the proverbial iceberg. Of course, we all want to make a map of something, but there's this giant latent possibility that the GIS is giving us in terms of analysis that in many cases we're not exploring, not touching. Many years ago, I was involved with people who were doing accessibility mapping. Happened to be in Spain, but it could be anywhere. So this is, I think, an interesting example of how we can go a bit further. So the notion of accessibility. We want to make sure that our population has accessibility to the downtown, or accessibility to jobs, or accessibility to the airport. Well, we can map this. But accessibility is not just something we can take a snapshot of. We need to create it. We need to model it. We need to build this map of accessibility. So we need to determine where are all the origins, the people, and where's the destination, which could be the airport. And then we need to calculate for each origin all of the possibilities for getting to the airport, and we need to assign to each of the links of each of these routes attributes. Is this a superhighway with no traffic, or is this a small road with lots of traffic? Right? So we need to be able to adequately represent what it takes to get from point A to point B through all the different possible routes. So this is something which we need to instruct the GIS to work on. Now, when I was doing this many years ago, the GIS was working on it all night. It was a pretty complicated process, and it would come back with an accessibility map for us. Now you can run this in just a minute. The result, of course, is a pretty map. And it's showing me that there's this nice bright red area where people have higher accessibility to, in this case, jobs. But I wouldn't be satisfied with that. I would say, okay, great, now I know more or less where the high accessibility is. Why is it there? Who are those people? Has it always been there? Will it be there in 5 years? So I would be tempted to go and start clicking on those polygons and ask, GIS, tell me more. So the person who has built this is going to have to think about that to be able to answer my secondary and tertiary questions. Because I'm tempted to ask more and not just sort of leave the map and show it to my decision maker and move on. I want to know, who are these people? Where do they work? And how much do they make? And what are their other characteristics? We can do that. On the right here, we've got another example of people's accessibility to their head of municipality. So how disconnected are they to the center of their municipality? We can calculate that based on straight line distance, or network distance, or minutes, or lots of different metrics. But this is just one example of the 500 different spatial analysis tools that are available in the ArcGIS toolbox to dig a little bit deeper and to analyze our data and not just show the data on the map. So Esri's been very, very interested in increasing our focus on spatial analysis. We've always been doing it, but I think not enough people have been understanding it and understanding the range of possibilities. So one of the things we're doing is we're creating a series of massively open online courses, MOOCs, free courses that can be taken online, anyone. We've been running these courses for a few years now. Most of these courses have between 20 and 25,000 simultaneous users. The courses run from 4 to 7 weeks, and they come around twice each year. So there's one of the courses which is on spatial analysis. It's called Going Places with Spatial Analysis. It's not currently running, but it'll come around soon. So if you search for Esri MOOC, M-O-O-C, you'll find 4 courses currently available. And this is for us a fundamental course, because this allows people to see, using very clear, concrete examples, what spatial analysis can do for us. And it's all online, no software installation. It's all utilizing ArcGIS Online. Because ArcGIS Online, many people don't realize, has increasing spatial analysis functionality in it. It's not just for looking at maps. In ArcGIS Online, you've got a little menu of analysis. And these are the same algorithms that we've transferred from the desktop up to the cloud. So when you run a shortest path analysis, or buffers or overlays, it's the same code. It's just running on the cloud instead of on the desktop. So there's a whole series of practical exercises on spatial analysis available. My colleague Christelle played a nice game with us a couple of days ago. And if you recall, the basis of her game were spatial analysis questions. And she showed this same slide. This is a PDF. This is a small book that's available. And it's called The Language of Spatial Analysis. And it has 26 very short 2-page chapters. And the idea is to communicate the types of questions that we would like to ask of our GIS in very simple terminology, such that we can explain to our boss or our grandmother at home what it is we're doing. Right? What does this GIS think about anyway? A whole series of questions. in different categories, such as understanding where things are, measuring sizes, shapes, and distributions, determining how places are related, finding the best locations and paths, detecting and quantifying patterns, and making predictions. In each one of these chapters is a very simple little vignette, very short story. In this case, are spatial patterns changing over time? And it gives it some examples. Why would we want to know about this? What are the types of questions we would ask in this category? And it gives you some suggestions about how you might want to do that. It doesn't tell you how to do it running the GIS operations, but it gives you an idea that these are the kinds of questions you would want to ask. And it's up to you or your GIS people to translate that question into the toolbox necessary to answer those questions. Another resource that perhaps you're not familiar with is a resource called Learn ArcGIS. So the URL is learn.arcgis.com. This is a group of spatial analysts, cartographers, scientists at our company who decided to start on their own to create learning materials, very practical. So there's a series of very practical, very short exercises here. And this website gives you access to the software as well. So if you're at home and you don't have access to your software from the company or from the institution, you can download it and you can use a personal license here to run these exercises. Or you can get an account on ArcGIS Online to run these exercises. There are many exercises, but if I've, in this case, filtered for spatial analysis, just in that category, I've got 27 lessons that were found. Building a model to connect mountain lion habitat, analyzing credit card fraud, predicting floods with unit hydrographs, a collection of different types of analysis. But with all the materials necessary for you to understand what's the problem we're trying to solve, what are the tools available, and what are the steps we need to take. You go through the steps and you've got an answer. Not designed for any specific person's specific needs, but so you get an idea of what's the range of possibilities with the spatial analysis tools. So that's learn.arcgis.com. Some of the same people, our spatial analysis team, recently published a blog article with, again, a whole series of exercises utilizing scenario-based case studies, specific problems to be solved. And so this is a website with links and links and links. Exploratory analysis, and if I scroll down here, analyzing spatial clustering, correlations, and there are a few other categories. There are 5 or 6 different categories. With just links and links and links to practical exercises where you can get access to the problem, the tools, and then the methodology. So I guess to find that, this was just published on the 18th of September. Search for Esri blog or ArcGIS blog, and you'll see this from September 18th. Very nice collection. So I work on the education outreach team. Sometimes we're frustrated because other people in our company are creating learning materials and this and that, and there's just more and more stuff being created everywhere around our company. And sometimes it can seem a little bit chaotic. But I think the positive spin on that is that there are a lot of people in the company who realize that our users are desiring more examples and more help to utilize the tools to solve problems. And so we're starting to see more materials being published, and these are all free materials. If you are a current user, you're on maintenance, you now have access to all of our online courses. Previously this was called the online campus or the virtual campus, and you had to subscribe, and you had to talk to your manager and ask, can I take this 3-hour course? I see on the menu that it costs $57. Now all users that are under maintenance have free access to all of these courses. There are 146 of them. And these are very specific courses. 3 hours, 5 hours on spatial interpolation utilizing ArcGIS, basic map projections, little specific topics that people have curiosity about. So if you're on maintenance, you're part of an ArcGIS organization, you can go in and you can take these courses at any time on your own. These have been very useful in many universities. Many professors don't want to spend a lot of time teaching the basics. I do the same thing with my students. I say, go online to the Esri site and take this course, that course, and that course. Each of these courses produces a PDF. It doesn't say that you did a wonderful job on the course, but it says you took the course. right? I say, send me the PDF showing me you've done these 3 courses, and then next week we'll start talking about the more advanced stuff. So this has become very interesting for a lot of our educators as well. You've seen, I think, from many perspectives in these past few days, the notion that ArcGIS is no longer a box on my desk, like ArcInfo was. It's now a platform that has lots of components, and maybe we don't need all the components, but it's interesting to understand what's available in the platform and to slowly migrate away from only desktop use to the situation which is very common these days, where the desktop becomes the publishing mechanism, whereby a few specialists are creating data and then they're publishing their data as services and as web maps so that others in the organization can consume them. And this creates more lower level GIS users. So it's a tendency which is going to continue. This is one of these IT trends that we're following. We didn't create this notion of creating a platform with servers and mobile applications and cloud applications and desktop applications. This is the way that the technology is taking us. Part of the platform, which is not software per se, is data. We're investing millions of dollars every year in content, satellite imagery, elevation data, oceanographic data, demographic data. And you're getting access to more and more sets of global data, such that no longer when you turn on the GIS do you get a blank screen staring at you, right? You can customize your own base maps, and on top of the base maps and the global data they were providing to you, you can start doing your own work. So you're not starting from scratch. Imagery especially. We're utilizing the same imagery providers that everyone else does. The digital globes and Airbuses and the same companies. And we're making that freely available to you because we want that to add value to our platform. We've heard a few people mentioning big data. Big data, of course, is a trend. Most people who say they're doing big data or want to do big data aren't really doing big data. But people who do really want to use genuine big data, which means collections of data that are not only so large, but so complex that we can't even understand them, we're offering tools for that now. So we offer a geoanalytics server, which allows people who want to take very difficult problems on huge collections of data, and to be able to move analysis of that data onto multiple machines, parallel computing. So we've taken certain of the analysis algorithms and we've moved them to the multiple machine paradigm. And so what you do is at your desktop, you decide, this is going to take me, either it's going to take me 3 days to process this data, or it'll never work because I don't have enough memory on my machine. I'm going to move that process up to the 20 servers which my institution has given me temporarily, and I'm going to run that routine in 5 minutes instead of 3 days. And then the system brings back the result as a new layer on my desktop. It needs to be set up, it needs to have IT support, but if people want to do that, it's now available. We have several different options for doing such. Some of you, I think, had a look at Insights the other day. Insights is essentially another user interface to spatial analysis. Many of the algorithms are the same, but rather than being a GIS specialist and doing the typical GIS operations, it's allowing people to much more, in the visual sense, drag and drop data on top of each other and start asking questions, visual analysis. This has become very, very popular, especially in the commercial world, but eventually it's moving over into other fields as well. I mentioned imagery. ArcGIS, the ArcGIS platform is now an imagery platform for all but the most advanced specialists. You want to do basic classifications and extractions and things like that. It's in the core. It's no longer an extension. It's in the core of ArcGIS. ArcGIS Pro is a very fast 64-bit graphical engine, and it provides some very nice image analysis capabilities. We've seen some examples of people doing field GIS, and I think more of that will happen. And in order to do field GIS, which means bringing the GIS capability out into the field, not just for data collection, but for analysis, bringing the possibility to be in the field and ask questions about what I'm seeing, and also to collect data and add data to the system. This assumes that we have published services. Another paradigm that some people are still a little bit hesitant to move towards. This means that I'm on my desktop, I've created a nice geodatabase for my own purposes. Oh wow, with one more or a couple more mouse clicks, I can publish as a service. And I can determine who I'm publishing to and who has access to this nice database I just created. And then it's out there, such that any of my colleagues can, a week later, say, I'm going to create a mobile application for the field. Okay, well the mobile application, most of it doesn't reside on the mobile device. It's calling services. Where are the services that I'm going to call? I hope someone published them. I hope my department over here has published the nice data that they created last week, because I need to consume them online when I'm in the field. So these two things go together. To have nice mobile applications, you need to be publishing and sharing data. So we're trying to make that as easy as possible. And so there's a collection of apps, mobile apps, web apps, that can be used as is, out of the box. They're actually not designed to be used out of the box. They're designed to be used as examples, because we offer your programmers software development kits to look at the example that we've created. Let's say Survey 123, which does a few things really nicely, but you're thinking, oh, I really wish it were in Swahili. Oh, I really wish it could do this. Fine, you've got access to the software development kit to extend that application, to improve it, to customize it. So we're going to start to see a growing collection of small apps that do specific things, rather than trying to take all of our desktop functionality and force it onto a small 4-inch screen. Doesn't make sense. It makes sense to have a collection of apps. Now I want to collect data. Now I want to analyze X. Now I want to share data, specific operations. And I think some of you saw the web app builder, a user interface allowing you to build applications without programming, without touching the code. You decide the functionality and the behavior of the application. I would like my mobile app to look like this and to behave like that. And then as part of the process, you decide at the very tail end of the process, oh, and by the way, I want to have a Windows version and an Android version and a Mac version. Our system then compiles all of your requests and creates the apps, and then you've got them available on different platforms. Changing gears just a little bit. I mentioned that we work with 11,000 universities. The 11,000 universities are now utilizing GIS in more than 100 disciplines. Proof positive that GIS is not just for geographers. I studied geography, I love geography, but I think it was a mistake for Roger Tomlinson to call his beast a geographical information system 50 years ago. If he had called it a spatial information system, everyone would be happy. But he called it a geographical information system. He was a geographer. And that, I think, has made it difficult for us to get through to the biologists and to the civil engineers. It's for you also, because you're studying something in space. If you were to go to esri.com/industries, you'll see sort of how do we categorize the world. Petroleum industry, public safety industry, natural resources. This is how we segment or how we categorize our 350,000 users. Well, our universities and our other learning institutions need to feed these industries. So where does one learn to become a GIS specialist for the petroleum industry or for a cadastral organization? So we do our best to work with different departments across the university, and we find out that of course the geographers are using it, of course the geomatic engineers are using it. But we're finding, for example, that archaeologists are using our software to look at the internal structure of bones that they've dug up. So they're not just saying, here's where I found the bone in X, Y, Z on the map. They're saying, no, no, I cut open the bone and I'm analyzing the cross-section of the bone with ArcGIS. I want to know about the internal structure of this bone. Who is this person? What did they eat? How did they die? Or people are working on cell biology in secondary schools, looking at the different interfaces and the different intersections between the different parts of the cell, using GIS. Or they're analyzing sports data, because increasingly sports events are digitized. And we know where the football's been. We know where all the players have been. We know where the tennis balls have been. And we can analyze this utilizing spatial analysis. Are the players in the right place? Do we have the right configurations? Or do we have to make modifications? So the big football teams are utilizing GIS to analyze if they lose. If they win, they don't do any analysis. If they lose, they analyze what's going on here. Let's see if we can fix things. A dance teacher, a choreographer at the Ohio State University, decided if the football teams can do it, I'm going to do it too on stage. So it has some video recorders on the ceiling that digitizes all of the dancers and utilizes spatial analysts in ArcGIS to analyze the dance routine in space and in time, and runs the dance routine back and forth and says, oh, stop. You people are in the wrong place. We need to fix something. Okay? So our users surprise us all the time. What do they all have in common? They're analyzing something in space, and we don't mind if they're in microbiological space, or in dance space, or in cosmological space. It happens that most of our people are in geographical space. But our users are surprising us all the time. All of us have seen this view of the GIS. The GIS is a sandwich, and we need to analyze the layers. Yes, and this is the box I was doing it on 100 years ago, right? Things have evolved. Roger Tomlinson, who invented GIS, wrote a very nice book for GIS managers. And he has a strategy of 10 different steps to take in creating a GIS. And he's reminding us all, GIS is a project, it's not a box on your desk. I won't go through any of the details for lack of time. But to mention one here in the middle, he says, what we don't want to do is to say, my boss wants us to build a GIS, we've got a bunch of data already laying around, what can we do with this data? What questions can we answer? And move in that direction. He says, no, you need to start by, what's our purpose? What are we trying to do? And then it might be that what we're trying to do cannot be answered by the data we currently have. So we have to make the tough decision to throw away all those years of data that are not going to answer our strategic questions and collect new data to answer these questions. So the key bit for me is in the middle, I think. Describe the information products. And what Roger Tomlinson always tells his audience is that you need to determine what are the products that the decision makers have to have on their desk or on their screen every day or every minute or once a year. So we have a strategic plan once a year. We want to know where the elephants are every 5 minutes. We want to know whether the FedEx packages are reaching their destinations in real time. And he said in most big GIS projects, you can come up with a list of 100 or more information products. This is what my boss wants to see on the screen every X time period. And then we can aim at that. That's the only thing that counts. If the decision maker is not getting these information products, then we're just wasting time creating data and in the field and blah, blah, blah. So I think it's a very interesting way to look at things. And this is the FedEx example. FedEx didn't call up Esri and say, send us 15 ArcGISs. No, they hired an engineering company, one of our partners, and they said, partner, this is our exact problem we need to solve. I want my decision makers to come in the morning and look at their iPad and be able to see very clearly on a dashboard, how's my business doing today? Do we have weather problems? Do we have accidents? Do I have any kind of logistical problems? And if I don't have any major problems, wow, I can start doing something else today. But I want to know what's going on. And in each of the vehicles, we want to have a customized navigation system. And it's linked to everything else, such that if there is a traffic problem, the driver knows about it immediately and gets rerouted. And everything's connected. So it's a customized system. And some people would look at that and not identify that as GIS. That's GIS. It's a customized solution. And so we need to be thinking in that perspective in education. The Port of Rotterdam, similar situation. The Port of Rotterdam, the largest commercial port in Europe, had a GIS for many years. They decided to publish a tender for a new GIS. We want to renew things. Esri decided not to respond as usual, saying, okay, GIS department, we're going to give you a new GIS. They said, no, there's this new way of utilizing GIS. Instead of having heady GIS for a few people, we're going to put all of the relevant information on people's tablets, such that any employee in the port can ask, where's this container going? Tell me about this ship. Where are the hazardous materials? With 3 clicks. Ask any question within 3 clicks. So these commercial customers are really challenging us to change the way that we deliver GIS. Because, again, it's not for the GIS department that has to print a map at the end of the year. It's for people who have to solve problems minute by minute. Distribution of beer, where to set up Starbucks restaurants or establishments. 7-Eleven utilizes mobile applications so that their salespeople can visit the stores optimally. Commercial real estate, near airports, shopping malls. How do we sell this real estate? How do we get people in, and how do we convince them that this is an optimal location for their business? So just as a reminder, of all the industries I talked about, this is the fastest growing industry for us, commercial. commercial. We're learning a lot of lessons from the commercial world, because the commercial world, as opposed to a planning agency, the commercial world says, I'm going to spend $1 million, but I'm going to get back more than $1 million in value right away, or you guys are in trouble. Right? So they really put the pressure on us to define what it is they need to do and then provide a solution. So I mentioned the online courses. This is the Going Places of Spatial Analysis. This is another one, do-it-yourself apps, which is ongoing now. It'll come around again in a few months. This allows you to go through all the steps necessary to create the apps, as I told you. Apps for phones and apps for the web. So again, it's one of these courses. It's roughly 4 or 5 weeks. Multiple Facebook groups, including a Facebook group for higher education. So we've got 16 or 17,000 people on this Facebook group talking about educational opportunities and grants and things like that. So have a look on Facebook for Esri. GeoNet is our own version of sort of a social community where you can go online and ask questions and get help, find out information about what's new. So concluding here, I might have gone a bit over time. We're really looking forward to see more people move from expository mapping, which is absolutely necessary, to higher level spatial analysis and problem solving. We think we're providing quite a few learning materials to help you to do that, and that we all understand that GIS is evolving naturally with evolving technology, such that more of our GIS is now on mobile devices. We need to understand what does that mean regarding publishing services, sharing data, etc. I showed you some of the online learning opportunities. Please have a look on Google. And then finally, that we, Esri Incorporated and Esri Eastern Africa, we're here to help you. We're here to help you learn. So please do contact us for face-to-face learning opportunities, or conferences like this, online opportunities, and we're very happy to help you to do that. So the final message here, that to be an expert on anything, you need to have a clear goal, and you need to put in the thousands of hours. Right? The thousands of hours. Right? The GIS is not going to magically solve any problems. You've got to put in the hours, and some of you know, right? Blood, sweat, and tears, right? Lots of late nights and weekends. But with the dedication and with the goal, GIS can help you to do some pretty wonderful things, right? So this is the case of marathon runners, right? If you want to be a marathon runner, you can do it at the highest level. You got to put in the hours, right? I can't do it, but they can do it. So thank you very much for your attention, and never stop learning.